so I did the second half of the transformations. So for my first example, we're going to be looking at how to form an equation from a graph. So in the last video, you learned how to form a graph from an equation, so this is the opposite. Okay, so here we have a sinusoidal curve, which does go on to infinity in both directions, and you can get a cos or a sine curve from this, but here we're looking for a sine. So you can really highlight any one rotation on here. We're going to choose this one. And now based on the one you highlighted, that's how you're going to find your equation. Okay, so I've written out the standard equation here, which you've seen before. So you know this is your amplitude, this is your phase shift, your vertical shift, and then the k value comes from the period. Okay, so here I've written some equations down to find each of these different parts. Of course, you should be able to find all of them from the graph, so these are just like a double check. Okay, so for our amplitude, you can tell from the graph that it is 3. If you did want to double check it, you can plug it into the formula and you would get 3 again. As for our vertical translation, we actually don't have one. As you know, the sine curve starts at 0, 0, and we have not moved up or down. So if you plug that in, you would actually find out that we actually don't have a vertical translation. Okay, and for our period is just 2 pi divided by k, but since we don't have the k value, we're going to look at the graph, and you can just tell from the graph that our period is 2 pi. Now that means we can solve our k value, and k is just 2 pi divided by pi, so in this case you're going to get a k value of 1. Okay, and the only thing we're missing is the horizontal shift. Now normally we would start at 0, 0, so we do have a shift to the left of pi over 2, because it is a 4 squares to pi axis, pi over 2. Okay, so now we have all of our information, so we can form our equation. So f of x equals the amplitude of 3. Now this is the standard equation, but this can change from sine or cos, but in this case we are doing sine, so we will leave it. And our k value is 1, so we don't need to plug it in. Now we did shift left pi over 2, which means we're going to have a positive pi over 2 when we plug it into our equation. And then we did not have a vertical translation. So this is our final equation. Okay, so for my second example, we're going to look at the application of transformation. So the only difference is we have to find our information from what they've given us as opposed to a graph. So the tides of Cape Capstan, New Brunswick, changed the depth of the water in the harbor. On one day in October, the tides have a high point of approximately 10 meters at 2 p.m. and a low point of approximately 1.2 meters at 8 p.m. Okay, so our first example says if a cycle begins at the highest point possible, model the height of the water in the harbor as a function of time. So here's our equation again, standard equation, because that's what we're solving for. And again, we have our values on the side. Okay, so if we're looking at the period, we are looking at time, and it wants 1 full cycle. So we know our period is going to be 12 hours. Okay, our amplitude, we're going to have to use our formula because we are actually given the max, which is 10 meters, and we are given the minimum, which is 1.2 meters, and that's all we're given. So we're going to have to use the max and the min to solve both of these. So if you plug the max and the min into the amplitude equation, you do get 4.4. And again, for vertical translation, if you plug the max and the min into that, you get 5.6 as your vertical translation. And the k value you can get from your period, k is 2 pi over pi, or the period, sorry, and you find out that you get pi over 6. And then we just need the phase shift, and if it does start at the highest possible point, we don't actually have a phase shift. So you can probably conclude at this point that you are going to be using a cosine curve because it does start at the highest possible point. So of course when we plug in the equation, this will change from sine to cos because it is just a standard equation. So f of x equals, we're plugging in our a value, which is 4.4. We're doing a cosine equation. Now for our k value, it's pi over 6. And we're just going to put t because we don't actually have a phase shift, so you don't need to include it. and then just plus our vertical translation. So that is our equation. B, we're actually going to graph it. So it wants a model of 2 complete cycles. So I started at 2 p.m. and all the way to 2 a.m. is 12 hours, so that would be 1 cycle. So we have to go back to 2 p.m., which would be 24 hours, which is 2 cycles. Okay, so since it starts at 2 p.m. and it starts at the highest point possible, we're going to label that as 10 meters. We also need our lowest point on the grid, which is 1.2. And we know our vertical translation is 5.6, so that will be our middle line here. Now it doesn't matter if this is to scale as long as you have your key points. Okay, so now we just have to plot a point. So at 2 p.m. we know it's at 10 meters, 8 p.m. we know it's at 1.2, 2 a.m. it's back at 10, 8 a.m. it's back at 1.2, and then finally 2 p.m. it's back at 10. Then we just have to go in the middle of each of these, and we know it's on our middle line here. So it's not too difficult to graph when you have all of your key functions. Now it is a cosine curve, so we're going to have to make this nice and curvy. We don't want any straight or pointy lines here. And it does continue on forever in both directions, okay? And now looking at the last part of this example, so a sailboat can move in water that is at least 2 meters deep. Can a captain safely sail out of the harbor at 6 p.m.? Justify your answer. So I've written out our equation here. Now, basically, we're solving for 6 p.m., which is a function of time, so we're going to sub in a value for t. We're not going to sub in 6, however, because if you look up here, we do start at 2 p.m., right? And we want to get to 6, so that is a 4-hour gap from 2 to 6. So really, we're going to be solving t equals 4. Not 6, because we didn't start at 12, we started at 2, so we have to compensate for that time. So basically we're going to be solving for h at 4, so wherever you see a t in your equation, you're going to sub it in for 4. So this becomes a 4.6, and basically you're just going to go through and simplify as much as possible. So cos, this becomes 4 pi over 6. And of course, that can be reduced to 2 pi over 3. I'm going to put that in brackets now. That. And we actually know the value, or can solve for the value of cos of 2 pi over 3. It's negative a half plus 5.6. And we're going to multiply that out to become negative 4.4 over 2. Plus 5.6. So h at 4 equals negative 4.4 divided by 2. Equals negative 2.2 plus 5.6. Which then equals 3.4. So therefore, yes, he can safely sail out at 6 p.m. and you're finished.